Let's go ahead and get started. Good afternoon and welcome to the third of Cohesion's four-part webinar series. My name is Jessica and I'm the marketing coordinator here at Cohesion. Today's webinar is the digital twin unlocking new value in commercial real estate, and we're very excited to have all of you here to dive deeper into digital twins and the benefits it brings to the industry. Before we get into it, I'd like to mention a few housekeeping items. We'll be addressing questions from the audience in the last 10 minutes of our presentation today. So feel free to submit questions at any time during today's presentation in the Q&A box. This content will be available later for on-demand viewing, and we encourage you to share with anyone you think you want to know more about digital twins. There's also a short survey at the end of the webinar, and it'd be super helpful for us to hear your feedback on today's event. All right, let's get started. I'm excited to introduce our panelists, Nick and Isaac. Nick Patel is the co-founder and chief technology officer at Cohesion. He's co-authored 2 patents on digital twin technology and leads the engineering and implementation teams at Cohesion. He's a brilliant engineer and continues to be an essential part of Cohesion's journey and success. Isaac Townsend is the senior product manager here at Cohesion, as well as our in-house building automation engineer. He works internally across all our teams as well as externally to develop innovative features and solutions for our customers. Most recently, Isaac was part of the team that developed and implemented our indoor air quality program. He is an expert in his field and an instrumental part of Team Cohesion. We're super excited to hear what you both have to share about today's topic. So with that, I'll hand it over to you, Nick.
Thank you, Jessica. Welcome everyone to our webinar discussing digital twin and the value it brings. Before we jump into digital twin for real estate, I wanted to take a couple minutes to discuss digital twin and its definition. From a historical standpoint, we saw digital twin as a word emerge spatially from NASA world during Apollo missions. During Apollo 13, NASA had built simulators that mimic the functionality of the space shuttle. And when Apollo 13 ran into issues, they used those simulators and all the data that sensors from the shuttle sent to Houston Control to make certain decisions to bring astronauts back home. From there on, we have come a long way, and we have seen digital twin being used in other industries as well. Manufacturing and industrial is one of the prime example of it, where all the assembly lines, etc., are monitored extremely well into a virtual environment, even though they are physical entities. Same for oil industry, where oil going from oil rig all the way to oil tanks, and how it's flowing is monitored through all the sensors. So when you think about it, fundamentally at its core, a digital twin is a digital representation of a physical entity. And that can take many forms, right, Isaac?
Yeah, absolutely. I mean, it's as simple as, gathering data from a single sensor, and can go all the way to, what many of us might sort of view and think of as maybe like the holy grail of digital twins, which is this sort of complete visual, live, interactive representation of that physical entity. So, as we're related to buildings, if we imagine a digital twin for a building on that scale, you'd be able to move around virtually inside that building, see the systems operating, see how individual parts of equipment are moving, look at room temperatures and set points, and look at where elevator cars are, right? So that's sort of where, I think everyone knows we're trying to get to. But maybe where we are now, maybe the most obvious visual representation that we have sort of as it relates to commercial real estate is BIM. The BIM modeling process, which stands for Building Information Modeling. And, the goal here is with BIM is that it sort of sets out to create a 3D replica of the building and the systems before construction. And, I mean, this has been around for well over a decade. And, what it really is that we're still sort of defining what this digital twin means for real estate and, how that's evolving.
Certainly. And when you bring that back into real estate, and how it differs when it comes to digital twin from other industries is the people that are involved interacting with the buildings in commercial real estate. So for commercial real estate, a digital twin is a simulation of all the operational processes and is fully representative of buildings' characteristics and behaviors. What this does, and as you think about it, the natural question becomes, why real estate should leverage digital twins, right? in a way, it is simple and pretty apparent that digital twin brings and unlocks all the new efficiencies into commercial real estate. It could be as simple as streamlining workflows that requires 4 people's attention right now to automated workflow. Some mundane task that building staff has to do that can be automated. And in turn, it increases the asset value as well. So ownership benefits from it too. The outcome of all of that is not only related to the building, but also to the occupants inside the building as well. With digital twin, we see a much better improved occupant experience as well. So let's look at how commercial real estate has evolved so far in terms of the technology and how we got to this point. When we think of how our industry got to this point, let's look at some of the buildings, I think a decade or 2 ago. Those buildings had disparate systems, analog or mechanical automation systems, and all the operations and processes were pretty inefficient, at least in today's standard. And what that ended up causing is more human capital requirement, maybe unhappy or frustrated tenants, but also in terms of the systems themselves, they weren't functioning at their most efficient level possible either. When you look at Cohesion's buildings today, those buildings are interconnected. It is a single platform that connects all the systems into the building into a single platform that in turn helps create healthy and sustainable buildings by looking at human interactions, external factors like environments, and all the systems bringing data into a single platform, resulting in a smart occupant experience, like I mentioned. From here on, with smart devices and systems creating smart buildings, we expect to see that with digital twin, and when we see digital twin in multiple buildings, we force that path towards the smart cities. So essentially, digital twin creates smart buildings and forge path towards the smart cities.
Yeah. And so, before we can create smart cities and smart buildings, we've got some pretty big hurdles we have to overcome. And it's mainly around, the data we have in buildings and the siloed nature of many of our building systems. And so when we look at air quality, just for an example, IAQ has become an increasing concern over this past year. And, many in the industry are asking themselves, how do we ensure that the air in our building is safe? First off, if you're not measuring it, there's not a lot we can really say about that. And if you are measuring it, but you can't tie it back to your building systems, there's not a lot you can do about it. How are you going to improve that? So one of the big things is, by adding this missing data and applying that context, interconnecting with your building systems and operations, a digital twin can become smarter and drive more meaningful outcomes. So in order to get smart buildings and smart cities, we really do need this digital twin and this converged data and systems. And the backbone that supports that digital twin is this contextual and connected data systems. So I think, what we're looking at here is really just a sample data pipeline, a data backbone that we have for getting data from the building into a digital twin. And again, this is very generic, but what we're sort of looking at on the left is sort of the building data, and the right is sort of the outcomes. And at the top left, we've got API integrations, and an API is just an application programming interface, and it just lets you, it's made by the manufacturers, and it just lets other people connect to those systems. And get data from them and send data back. So we see this a lot with access control in elevator systems. So this is something, if you can connect to that API, you can start interacting with those systems. We see a lot of physical devices, and with the rise of IoT, we're seeing more and more connected devices in buildings, and they're using a variety of protocols. So, there's always been some physical devices in buildings. Those who are familiar with the building's mechanical systems, you see a lot of BACnet, Modbus, Lawnworks, things of that nature for HVAC, lighting, etc. But more of the IoT devices and the personal devices are coming on with just regular Wi-Fi or LoRaWAN, Zigbee, radio frequencies, just all these various protocols, and the list goes on as IoT evolves as well. And so many of these, because of the protocols used, they need that translation layer before you can actually make sense of that data that is coming through. And then, one of the more recent trends in prop tech is the tenant applications and the engagement side. And the big thing here is that this is really another rich data source that really represents the people side of what's happening inside buildings. And so, some buildings have this, some buildings don't. But what we're seeing a lot too is that even normally if these data sources are available, they're still pretty siloed and they don't work well together. And so, with the digital twin, they're converged to create, a powerful feature set. And so, what's the point? Like, what happens when we bring this data together? What does it allow us to do? And so, when it comes to those feature sets, just some real life examples. With anything in a building, there's always going to be these competing priorities. And with disparate systems, it's difficult to balance those priorities because they don't work together. And so, if we start to look at, let's just take energy, for example, in a building, it's actually very easy to reduce energy in a building. You just turn everything off, right? But, you end up with not a very good environment for your tenants. It's going to be uncomfortable. The air quality is going to be pretty bad. I think that's all pretty obvious. So, what do we do right now? How do we balance that? And the fact is we are using data, but we're just using the data that's available to us at this moment. And so a lot of that just lets us turn equipment on, off, or adjust set points, using the data we have, which is when we think people are going to be there. So we're doing a lot of scheduled control. And so one of the ways we can solve that to a certain degree is by, let's tie together the access control system, the card readers, occupancy sensors, bring this all together. So instead of operating our building, from 4 a.m. to 6 p.m. every day, let's operate it when people are there. And, there's where you can sort of glean some of that efficiency by tying this together. And then, bringing back to air quality, because it's just such a big topic of discussion now, is how do we provide a safe and healthy environment for our tenants? And, as I mentioned before, the first step is still to measure it. And a lot of times that involves installing third-party sensors to gather that missing data on the air quality. And so, but again, measuring it's one thing, we have that. And so now we can start sort of paint this picture of what the indoor air quality really is in a building. But again, if we don't connect that to anything, it's standalone and there's not a lot we can do about it. And so, what happens if the air quality isn't good or if it varies throughout the day in different places? So, again, if you don't connect it, you're sort of left enacting these sort of large sweeping changes to the entire system, which is not going to be very energy efficient, and it's probably not going to be very effective either. But if we can tie that sensor data together with the spaces and the HVAC data, the equipment that serves those spaces, we can start to, really affect the air where we need to affect. We can optimize the air quality where it's needed rather than trying to optimize it everywhere. And then, again, we can take that one step further. We can tie that together with occupancy data and further optimize only when people are present, right? And so, these are sort of just two very real scenarios that revolve around energy and IEQ, but there's also sort of the asset side, the maintenance side of a building. And just like with the energy example, if we don't have that people side of the equation, we're left doing our maintenance off of a set schedule, right? Or you can take the run it till it fails approach, which is actually more common than you might think. But if we can tie that together with some operational data, maybe instead of just replacing fan belts every 6 months or a year, whatever that is, you've got this data now, you can be more intelligent about it. So, you can replace it maybe you can extend that to 1.5 years, every 2 years now that you're actually monitoring that. And so you can gain that efficiency and keep that reliability. And so, this is really one of those things where, it's really going to help out on that side of the equation as well. And these are just a couple real world examples of how a digital twin can really impact commercial real estate. But I think, let's discuss some of the trends we're seeing in the industry now.
Yeah, so from a prop tech standpoint, we are seeing a few trends on how the adoption of digital twin will go. It is pretty common for any technology and digital transformation to go through this S curve. It always starts at the bottom, and we are at the bottom when it comes to the adoption of digital twins, as we as an industry define it as well. From going through that bottom where technology is a novelty, we will get to the top where technology is a commodity. And the path from that novelty to commodity is what real estate industry will take through digital twins to create those smart buildings. Let's draw that path out in terms of how will we get there. The first thing, like Isaac mentioned, if you can't measure, you can't improve. So the first thing that absolutely needs to happen is connected buildings. Connected buildings, both from a networking standpoint, as well as system standpoint, the systems that are interoperable. And it is gonna be the absolute first step of it. Second would be healthy buildings. Healthy buildings, indoor air quality, like Isaac mentioned, IAQ is one part of it. And second part is the building's health, which is the resiliency of the building and building's ability to react to certain faults that happens in real time. From there on, we get into intelligent buildings. The first two steps gets us the data that we need to be able to know what is going on and do the descriptive analytics per se. Intelligent building takes it one step further, and now it starts to stitch together different flows and automate them, streamline them, so that things that used to take 4 people in 10 days now takes 10 seconds. From there on, advancing the technology even further with machine learning and artificial intelligence, building can learn from that data and push actions back into the building itself so that it is self-healing and autonomous. It knows how to prepare for the changing environments around it. And that is how we would go from bottom of that S curve to top of the S curve for adopting digital twins in the building and unlocking the value. Now, that again brings up the question of, okay, let's say we did that. What would the future of CRE would look like having the digital twin? It would be we will have a single platform for all of the requirement. This is not to say that there is going to be a monolith platform, but more so a single platform that interacts with multiple systems and can pass actions back and forth between systems, can connect data between systems. By doing that, like I said, we get to that intelligent and autonomous buildings that will create adaptive built environments. In other words, everyone has certain level of a preference on how they want their surroundings to be, and buildings will be able to react to it depending on the data that is coming into the data warehouses, like Isaac mentioned, through all of these various data sources. Obviously, that results in sustainable and healthy buildings. And with the recent push in going carbon neutral, it is extremely important that we have our buildings use digital twins to be able to achieve that. So overall, what digital twins do is they unlock the successful future of CRE.
Yeah, and Nick, I was just going to say too, I think we've harped on data a lot because we both know how important that is for digital twins. And I just wanted to ask, what do you see? What kind of data do you see as critical for the digital twin?
That's actually a very good question. You can categorize data in 2 different categories. One is a static data, and second is a streaming data. Static data, like you mentioned, right? It is a data that does not change as much, but it is taken point in time. For example, building information model. It has all the information about how the building is structured, different floors, how it's converted into different spaces, things like that. This is the data that does not change as much. When you think of it from system standpoint, Think of mechanical engineering and plumbing drawings that outlines all the HVAC components and how each HVAC component is serving various spaces, be it your VAV box, fan power box, air handler unit, etc. When you think of it from a people standpoint, it is data about your occupants. Where are they leasing the spaces? What is the occupancy looking like, or max occupancy would be for those spaces? This is the data that is static. However, it is critically important because it creates the context around why we should or should not take certain actions. And while this data rarely change and is normally created during construction phase of the building, it is critically important. The other sets of the data is the streaming data. This streaming data comes throughout operational phase of the building. So when you break it down, it's about 20% during construction, 80% of the phase during operational phase. And we know every action generates a data point. When you scan your key card at the turnstile, when you call an elevator, when you invite a visitor, when you reserve an amenity, when you create a service request, all of that creates a data point. Not only that, all sensors and systems generate data. Indoor air quality sensors that you mentioned generates data at least once a minute to measure the air quality. HVAC systems run on a schedule and tell you if your fan power box has fans running or damper is open or not. And you know what? Even on the accounting side, it generates data, and all of this data keeps flowing in.
Yeah, and Nick, I actually just wanted to interrupt you here for a second. I just pulled up some stats that I always like to share when we talk about data. And I just got them up here. And then this is a real life example of like one of our buildings, which it has 40 floors, 704 defined spaces, spaces being like a loading dock, a restroom, a suite, mechanical room, just any space there. 66 HVAC zones, 39 tenant suites, 446 assets. And so when you combine that with the over 1,900 people in the building every day, what we're coming up with is thousands of interactions every second, right? When you start thinking about the breadth and depth of that kind of data that's being generated on a minute by minute basis, I mean, it's enormous. And it really just harps on the need to have a system that maps out all of this so that we can better influence the interactions so that we can automate them too.
Yeah, definitely. And real estate industry in general has done a pretty good job at building the simulations for financial side of things, and to a certain extent for building automation systems as well, depending on where they are in the journey of upgrading their systems. However, we have not gone much beyond that. We do hear how important it is for owners and property management to know the space utilization, but it is only done on ad hoc basis, mainly because people that run these reports are normally have to rely on either building engineering staff, security staff to generate these reports for them. And a true digital twin changes that because it connects all the systems and brings static and streaming data into a single platform. It normalizes the data so that building can gain insights and display to them for various constituents in the format that they understand. And now take this one step further. Now that we have the data, add artificial intelligence to it. It will learn from this constant stream of data coming into it and adapt to different behaviors and changing situations. And what we have seen is even when people understand that digital twin is the way to go for next steps, I think the question that we generally get is, how do we implement digital twin? And how do we create the path for digital twin for existing buildings? Well, you have been in industry for a long time. How would you go about doing that?
Yeah, of course, and sort of what we had talked about earlier, where the definition of a digital twin is still evolving. It only makes sense that without a really solid understanding of what a digital twin really is, naturally it is, well, how do we use it? How do we implement that? And so, I think conceptually, the path to creating a digital twin is actually really simple, but in practice, it's just very fraught with challenges. But the key really is the convergence and the context. So it's bringing all your data, all your systems into a single platform, contextualizing that so that analytics can produce insights and insights can produce actions. But, again, how that gets done is where it really gets challenging. And it does require, experts in both building systems and technology. But, again, it's more than just the people. They've got to have progressive mindsets to sort of go beyond what we've been doing for the past 70 years and get into the unknown. And, that's really kind of what we're doing here at Cohesion. And, just on that topic too, alongside the implementation of digital twins, I think just as often, we get the question of, how do we go about doing it? We hear a lot of discussion around the use of AI and ML and digital twins. So, I was going to toss it back to you to see if you could, maybe touch on that a little bit.
Definitely. I think all of us agree that the ultimate goal of digital twin is to offer tenant comfort while ensuring most efficient operations possible to increase asset value and ROI, right? We know technology brings all of that together and makes it happen. We talked about backbone being the interoperable technology as well as connected buildings. But coming back to your thought about artificial intelligence, AI, fundamentally, it is essentially computer making decisions based on predefined algorithms with adaptive actions to changing situations. Now, I know this may sound like too heavy as of a definition, so let me, I guess, break it down. I'm sure everyone has seen this in a gaming world, whether you play it or not, whether you realize it or not. When you're playing against a computer, it is essentially artificial intelligence playing against you, right? Be it your old Nintendo retro games or multiplayer games that people play today. Not only that, we have seen that in enterprise world as well. Everyone knows about Facebook's social media algorithms and Google's advertising algorithms. What they do is you say, I want a camera, and next thing you know, you're bombarded with all sorts of camera advertisements, right? All of that is an artificial intelligence. In real estate industry, like I said, have heard about this in space utilization. But when you break it down, let's break it down to keep it simple. We know the data is the backbone of it. We know we need static and streaming data so that we can create context around it. And through streaming data, we can take actions from that. Right now, today's system, even when they say they are smart systems, they are still siloed. So take an example of me as Nick Patel. I go to a building, I scan my key card at the turnstile, and it opens the door for me. Well, good. It's a single variable. When I scan at the turnstile, a single variable saying, am I supposed to open the door for you or turnstile for you or not? Great. Add some smartness to it. We would add destination dispatch. And when you scan, well, we will call an elevator for you because you know that you generally go on floor 10. Great. So far, what we did is we streamlined the workflows and we made technology operate with each other, right? From here on, the journey of artificial intelligence starts. The first step to it is machine learning. Machine learning, essentially what it does, it starts to make decisions based on multiple variables instead of a single variable. So instead of just saying, oh, someone scanned the card at the turnstile and I'm going to do a destination dispatch for elevator, what it does, it starts to recognize patterns. Nick Patel goes to floor 10 every single day, except for Thursdays, because for some reason he goes to floor 11. Well, Nick Patel knows he has a meeting on floor 11. What machine learning would do, it would look at the pattern and say, well, it's today's Thursday. I know destination dispatch itself would call floor 10, but I know Nick Patel will, with 90% certainty, will show up on floor 11. And because that is going to happen, let me check my air quality sensors and make sure that the air quality is looking good. And if it's not, I'm going to command HVAC system and bring in fresh air to get it ready for Nick Patel to show up. Now, this is where we started talking about machine learning and building, adapting to a changing situation through the streaming data that flows into it. And that's great. Well, you could do this, someone would argue you could do this with rules-based mechanisms, right? It's just simply, yeah, okay, you are going there based on pattern, good to know. But where we can flip this a little bit better and where AI becomes much more important is not about the decision itself, but about when to actually make that decision and when to trigger that decision or stop a decision from happening. That is what actually creates that efficient operations that results in energy savings, healthy buildings, things like that. And along the same lines, we also get asked about, that is great. How do I make my buildings more sustainable? How do I hit my sustainability goals and healthy buildings? How do you go about tackling that?
So this is really, where the power of a digital twin almost sort of becomes a requirement. Building occupants are demanding healthier environments. We're seeing, they're looking for increased transparency into their building, and with regulations and social changes, you're driving new sustainability initiatives. These are things that are just moving light years faster than our current building designs. And even in a lot of ways, the way we're thinking about our current buildings. With anything, like, again, we've got so many competing and opposing priorities in a building here. And, the question becomes, how can we optimize for all of them? And, the thought of using a digital twin for that might seem a little overwhelming, but, I'd actually make the argument that it's probably even more overwhelming and in many cases, not even possible to do without the use of a digital twin. And so in the short term, we can probably get by still squeaking out some low hanging fruit and getting by on some, making things a little bit more efficient. But I do think that of our current paradigm, it's going to run out. And, AI and ML powered digital twin technology is going to be a requirement. It's going to be necessary to satisfy the more complex and competing needs, of our built environment.
Agreed. That's actually been a good thought. It actually makes sense when you think it like that. And I do see that there has been a few questions trickling in. So Jessica, should we get into questions?
Yes, let's go ahead and get started with some questions. Thanks, Nick and Isaac. For the audience, if you have any additional questions, please feel free to drop them in the Q&A box as Nick and Isaac give their answers. So we'll go ahead and get started with the first. What do you mean by tenant experience? I'm sorry about that. What do you mean by tenant experience, tenant applications? Could you give examples?
Certainly. So when you think of tenant experience application, think of it as when your occupants are in the building, especially for commercial real estate, they need a way to interact with the building. And being able to do that with an application on your phone, be it an iOS or Android, or on your desktop through a web platform, what you enable is what Isaac mentioned in terms of application that tenant would use to take certain actions, like creating a visitor or using their phone as a badge to get into the building. Offering this sorts of application is critically important. Cohesion actually has an application that it offers for that because it captures the data from people interaction. Like we mentioned, the context around data is critically important, and it is critically important to also understand the actions that people are doing in the building. Obviously, while making sure that we attend to their privacy concerns as well as the security, it is still critically important for commercial real estate to offer applications for tenants.
Awesome, thanks, Nick. Second question here, what do you see in the future for those who implement digital twins?
I would say they are pioneers of long-awaited technological advancement, and if I were to throw a big word, digital transformation in real estate industry. Folks that implements digital twin won't only force the path towards the better future through smart cities, but they will also reap the financial benefits of all the efficiencies that digital twin will bring to their buildings. They will have leverage to attract best tenants and retain them while reducing operational expenses. They will focus on solving tomorrow's problems to stay ahead of the curve. And for what it's worth, when the next pandemic hits or when the next recession hits, they'll be prepared for it instead of reacting to it.
All right. Third question here, what role does Cohesion play in normalizing the data such as BMS, etc., being acquired into industry standards such as Haystack and Brick? Is this a function performed in or outside of the warehouse as a prelude to performing analytics?
Nick, what do we say? Let's double team this. I'll take the first half of that. Jessica, if I heard that right, it's what role does Cohesion play in sort of normalizing the data, BMS, and then tying that together with industry standards, Brick and Haystack?
Yep. Mm-hmm.
Yeah, so we do that. That is a role that we play, and it's one of those roles that is very necessary. It's not something we do just because we think it's fun, but if you don't do that, you're sort of left developing a system that's sort of a one-off, right? So if you're just doing things that are specific to one building, and let's just say you want to monitor a fan power speed, and you end up just hard coding in whatever that BMS name is or whatever it is for that building, that's great. But, when you move on to your next building, you're going to have to redo all of that. And so, really what our focus on is, building systems around how do we make that tagging and contextualization better, so that we can build one feature, one set of algorithms, and then apply it against those industry standards, so Brick and Haystack, right? And so that is something we do, and it just really just depends on how far we take it. It really depends on how far we're looking to go in that specific building. And so again, yeah, that is something we do. A lot of times we have to do it on our own. But it would be great if we could come across buildings that sort of already had this implemented. But I'm going to toss it to Nick, which is more of sort of, it sounds like an architecture question about where that actually happens.
Yeah, the question is, when we take these actions, the function performed, is it outside of the data warehouse or to preclude any performing analytics? That is actually a good question. I think the answer is it really depends. There are things that are better suited to happen in the warehouse, depending on when that action needs to be taken. I will take a very simple example. Let's say we are, Cohesion's platform saw that indoor air quality was degrading a little, and it commanded HVAC system to open the damper, right, and bring in fresh air. Well, that would actually start from cloud. It would start from data warehouse as well as a few other areas of the system. And that will not necessarily create the performance concerns. However, one of the things that we generally keep in mind is while doing that, we want to make sure that sending that command, if there for some reason the network connectivity was lost, we can relinquish those controls. Right, so it happens with a combination of data warehouse, which is in general cloud computing, as well as edge computing.
Thank you. All right, what's the difference between smart building and digital twin, if any?
Again, a very good question. So for what it's worth, in industry, it is being used as a synonyms of each other, call it smart building or call it digital twin. I think I personally believe that there is a difference. A smart building, again, generally acts as an entity of its own, inside its own. And you could create a smart building by adding smart systems. That is great. However, digital twin actually takes it one step further, not only in terms of the actions and reactions or adaptive built environment that we mentioned, but also doing things that might be outside of the building as well, which is when we get into digital twins that would force that path towards the smart cities. So in a way, I believe to a certain extent, both of them do the same thing. However, digital twin would trump the smart building as a definition when it comes to going beyond what the smartness could offer outside of the buildings and building factors themselves.
Nick, I'd even go so far as to say, if we get a little bit pedantic, it's almost that, a digital twin is sort of what's going to power your smart building, right?
Agree, totally agree.
Thank you. Next question here that we have is, when is the right time to implement digital twins or start considering it?
I'll jump in here just because, I've been in the building world for a long time. And this is one of those things where, I'm going to go out on a limb and hazard a guess. Nobody's ever said, I wish I didn't plan that so well, or I wish we didn't start thinking about this sooner. And in that vein, I think ideally, when's the right time to start thinking about it is it's during the ideation of that building, when you're sitting down and defining what do we want this building to be. And so, the whole point there is that, we can start thinking about this building to be designed and built smart rather than being retrofitted. And getting back to our question about, what role do people have in tagging this data? If you're going to make a smart building, right, and you're going to have these interconnected systems, you can make sure up front that your whole building is designed that way, that the nomenclature is consistent, things are tagged appropriately, and that this foundation is built. So when the time comes to do these more advanced things, you're already set up for that, right? And so, that's obviously, the perfect scenario. But I think I remember a stat, and this was in passing, so don't quote me on this. And actually, I realize I say that with a recorded webinar that's going to be immortalized on the internet forever. But it was something along the lines of like 80 or 85% of buildings that are going to exist in 2050 have already been built, right? And so we're already outside of that ideation phase. And so most of our buildings are already sort of in this operational phase, which, we all know is where the majority of data gets generated. And that just means, you have to go back and map and contextualize that data, using these schemas. And it can be challenging because a lot of times the systems weren't designed and nobody thought that this was ever going to happen. It was never going to leave its silo. And so it's definitely a big hurdle. It's not easy, but it is something, that we do every day.
Awesome. Thank you. How is Cohesion different from a BMS?
Ooh, this is a loaded one. So, the BMS is your building management system. And I think what we can kind of go back to is, I can't remember which slide it was, but we had smart devices, smart systems, smart buildings, and then smart cities. And so a BMS, if it's done well, you can consider that sort of a smart system, right? It's got automations, it has data, it's controlling things. And, that's what that is. But, where we come in is, we don't limit ourselves to that silo. We're connecting to all the systems and, making optimizations based on that. And, I think that from a high level, where that difference is that, we're pulling all of it together to create a digital twin to better optimize the building. From a physical standpoint is, a building still gets built. It still needs to have controllers. It still needs to have actuators. It still needs to have motors. And from that standpoint, that is also where Cohesion and a BMS system differences. We're not coming in and necessarily installing your controllers. We're not coming in and installing actuators and doing all of that stuff. We're really there just taking control of what's there.
Yeah, and also I think it is worth calling out that BMS is one system in the building. There are quite a few others, right? When you look at access control, when you look at elevators as physical systems, also work order, which is CMMS, when you look at visitor management, amenity reservation, there are quite a few other systems. And then obviously you could go on to financial side, but Cohesion comes in and integrates with all of them, while BMS does not. At least in most cases, they do not. I have not seen a single instance where BMS even tries that. So Cohesion is different from that standpoint, that it takes more holistic view than the systems itself. And that is why we keep mentioning people interaction and context around the data of why certain thing happen is important, which Cohesion focuses on. It augments BMS and works with BMS versus competing with BMS.
Thank you. Who owns the data you collect from building systems?
That is a very good question. The way I would put this is whatever data is created in the building owns that. For Cohesion, we strongly believe in that this is building's data and building owns the data. We did not, what we do have is we have a license to use the data to create the autonomy into the building and provide more value to be able to take actions from this data coming in. But after all, the data is owned by the building themselves.
Awesome. And we have a question here. Do you feel that we're on the cusp of a windfall revolution in the prop tech industry once crowdsourcing is achieved? Once buildings digital twinning could provide insight for other similarly situated buildings to also prepare to take action?
So I believe so. If anything, pandemic has been a catalyst for us to speed track the digital adoption, for lack of better terms. And I do believe that it will continue to get better from here. It is definitely the intent of digital twins to be sharing the data, be it the simple baselines of how they are performing against other buildings, or it could be as big as, like I said, going into smart cities where each building is providing that data into macro frameworks so that energy grids and systems that are set up at the city level beyond urban areas is set up well and could be leveraged to their best efficiency. Obviously, it goes without saying we start small and take it from there, and that start as a first step is connected building all the way to smart buildings to digital twins and beyond. And from there on, buildings start sharing data between each other.
Yeah, and I was going to take, the it depends approach to it for two reasons. Really, one of them is that, and I can't remember what it, again, I know another one of those like stats quotes here in passing, but it's always sort of like you tend to overestimate the change in technology in 5 years, but underestimate the change that'll be in 10 years, or it's the opposite or something like that. So I do think it's one of those things where it's probably going to come a lot faster than a lot of us think it is, especially those of us who are working on actually building it, because it's a really hard problem to solve. But I think about in terms of really the windfall and, if you get one done, does that scale to the next? And this is the tricky part, because if you build that digital twin in a way that doesn't scale, so again, getting back to the tagging and the context, because it's just so very important. If you don't do that and you build a one-off digital twin for one building, you're going to take some learnings to your next building, but you're not going to take that framework. It's not necessarily going to scale, where if you do things in a more generic fashion and you build that digital twin, now you've got a scalable framework that you can use and you can apply in other places. So, we've got technology changing, but then we've got, how are we building our systems to be able to handle that change?
Thank you. Here's another question here. How can digital twins help beyond the commercial real estate industry?
So digital twin in commercial buildings, I think I would like to bring that point home, right? That digital twin in commercial buildings is a start to bigger and brighter future towards the smart cities. When you know each of these buildings are how they're performing, you can start to make those decisions at macro levels. And we start to share data beyond real estate industry as well. It includes transportation, energy grids, waste, and water management. You could start to work through planning the people flows and creating new opportunities beyond the cities themselves. Not to say that none of this is happening today, but with the efficiency that we could do it, changes drastically with the adoption of digital twin. So in essence, it elevates the lifestyle. For example, if you ask a 10-year-old today if they know about what a floppy disk is, they'll just stare at you like, what language are you talking about, right? And that's because technology has advanced really fast when it comes to computer industry. And this is what we will see with digital twins as well. they will become an integrated fabric of real estate and built worlds in general. So, you know, in about 5 to 10 years, probably we won't be asking what is digital twin or why should we be doing it, but rather the question would be, hey, you don't already do that, you know? So I would say it is a start, and we start with the industry itself, but we go much beyond that and start to work with other industries in the built environment worlds.
Great. Sounds good.
Mhm.
I'm looking at some questions here to see if we have any more coming in. Seems like we're mostly addressed all of those questions. So with that, you want to go ahead and say, oh, wait, actually one question just came in. All right. Is your platform ready for use or open platform for us to develop specific applications related to building on top? If yes, are API available for that?
That is a very good question. When it comes to Cohesion, the architecture is built with API first in mind. Obviously, we strongly believe in interoperable technologies, and we are the one as well. Each of those APIs are consumed by our UIs today. We are working through upgrading certain components of those APIs to be able to make the public APIs available sometime next year. At that point, not only we would be connecting with all the other systems would be able to come in and connect with us as well. So with that, like Jessica mentioned, I appreciate everyone joining the webinar today. I certainly enjoyed all the questions come in and answering them. And I'm sure when I say this, I'm speaking for Isaac as well, that while between us, we had a very great discussion about digital twins. Everyone who participated added the same value as we did on this webinar. So at the end, I will leave everyone with this thought. Think how you can leverage data from multiple systems through a single platform to build your own digital twin. And if you need to reach out to us, you know where to find us. And with that, thank you so much for joining.
Thank you, Nick and Isaac, for giving us such informative content. This is the third webinar of a series from Cohesion. So join us next week for our final event, Data for an Engaging, Healthy, and Green Building, where Cohesion CEO and co-founder Dhruv Shivakumar will discuss the power of leveraging data for elevating building health and sustainability through autonomous building technology. So thanks again, everyone, and we'll see you next week.
Thank you, everyone.
Thanks, everybody.